Hi, welcome. We're going to be speaking in English because Terence isn't quite fluent in Icelandic yet.
Hope so.
Well on his way. So I'm Bryndís Nielsen.
I'm Terence. So we introduce ourselves in the next slides. Oh, yeah.
Yeah.
Yeah, so who am I? I'm Terence. I'm the plant manager at our latest direct air capture plant, Mammoth. A journey of many stops, as you can see up there, many different countries. I grew up in Singapore, actually. Got itchy feet and went to France for my higher education. I went to college in Paris and made a few stops along the way, exchange programs, internships, and so on and so forth in Canada, Spain. Went on to work in the chemical industry for 13 years with Solvay, a Belgian chemical company, in France, Italy, then the US. Did my MBA at Wharton in Philadelphia and woke up one day and said that I needed to fight climate change. So I put on my Superman suit and I flew here to Iceland with my family in January. So as of January this year, I joined Climeworks to lead and to operate the Mammoth plant, which we'll talk about later.
Yeah, sorry. Yeah.
What are you?
I am the communications satellite for Climeworks in Iceland. So I came on board with Climeworks when we opened Orca, which was the first commercial direct air capture plant in the world, which opened in Hellisheiði in 2021. And now with the Mammoth opening, it's been quite a journey. I have a background in psychology and anthropology, but I've been working in communications with Athygli for almost 20 years. So, yeah. We wanted to start with a little intro video.
Yeah, of course. He looks better than us and speaks better than us, so we let the CEO talk.
So this is Jan, and do I just press continue and we'll play?
So currently the world is emitting about 40 billion tons or 40 gigatons of CO2 every year. According to climate science, we need to reduce that essentially to zero by 2050.
On the one hand, we have to have drastic emission reductions, which is roughly 90% of the challenge.
But we will always be left with a certain amount of unavoidable emissions.
In some recent research, we've looked into about 500 scenarios that keep us below 2 degrees, as we say we need to do in the Paris Agreement. And almost every one of those scenarios, we need gigatons of carbon removal.
If we succeed at everything, if we succeed at efficiency and renewables and nuclear and electric vehicles and buildings and hydrogen, if we succeed at all of that, we will still need 10 gigatons. That's 20%.
We do need permanent carbon removal to achieve net zero. And when I mean permanent removal, I mean a solution that's permanently store CO2 underground, such as, for instance, direct capture, so anything that Climeworks is investing on.
This is Orca.
The advantages of Climeworks direct air capture technology, one is compared to other carbon dioxide removal technologies, it doesn't use arable land. That's important. Second, it uses energy, but that's becoming something that we can access with cheap renewables, so that's becoming really important. And third, the modular design means that it has the possibility to go down the learning curve in the same way that solar and wind.
There are technologies that are proven and they're in the field, and Climeworks is probably at the top of that list as far as proving that their technology does what they say it can do.
One of the key things to building this new industry and market is trust. At Climeworks, we have established the world's first full-chain certification methodology, and we are delivering third-party verified carbon dioxide removal.
As we look forward and we get into the part where we need removals, and we need more removals than was previously projected because we are just so slow with the reduction, we need this tool to become available to us, and the only way it becomes available in a material way is if we do the investment behind it now.
Most of the carbon removal capacity that will be online and available in 2030 will have been designed by 2025.
It's an urgent need because we need to see the demand now for these markets to truly scale and get capital off the sidelines. But when I think about why you might want to get involved, also consider the fact that this is likely to be a very supply-constrained market. And as we move towards 2030 and beyond into lots of commitments coming due for corporations, you're going to want to have the highest quality, removal technology in your portfolio of carbon credits. And Climeworks is at the top of that stack.
All right, so that concludes our. When we're talking about carbon capture, we are, of course, looking at a much larger picture. We not only need to be capturing carbon, we also have to reduce emissions. That's, like they said, that's 90% of what we have to be doing as a global community. But we will still need to remove CO2 from the air because we've been pumping it into the air for way too long. So our plan, our focus is on the unavoidable emissions and the historical emissions. We are not here to replace the need for reduction of emissions. Just to be very, very clear on that. So if you can look at this picture here, we need to, of course, reduce as much as possible. And then we also need to remove the unavoidable emissions. And for that, we have carbon removal solutions. The hope is to reach net zero by 2050. We'll, fingers crossed that will work. We're not seeing as drastic actions on a global scale as we had hoped for. But we have made our calculations at Climeworks, and we have calculated how fast we need to be scaling up in order to be climate relevant by 2050. And Orca and Mammoth are the first two steps in that scale-up process. So you can't just start with the gigaton industry, you have to start somewhere. And like I said earlier, Orca was the first commercial plant ever in the world. And Mammoth is almost 10 times bigger. But how does it work? So we remove CO2 from the ambient air. That is more tricky than it sounds. Usually when we're talking about capturing CO2, we are talking about capturing from smokestacks from factories, at which point you have a very high concentrate of CO2, right? In the air, we have 0.04% CO2. And that's the same whether you are up in Hellisheiði or if you are in Seattle or Paris or in a highly congested area like that. So you can be in Iceland or you could be in Louisiana or Norway or wherever you need to be. And like they mentioned, we don't need any arable land, and it's also highly efficient. Yeah,
maybe let's stop there for a moment. Can anyone do the math? 0.04% of CO2 in the air, 400 ppm. How much air do we need to capture 1 kg of CO2?
I can't even do that. So.
0.04%, 400 ppm. Yeah. All right, I'll give you all the answer, but to capture 1 kg of CO2, you need 2,500 kg, 2,500 kg of air to run through those collector containers. So just to give an idea of magnitude, not to test your math, but just to give you an idea of magnitude of how much air you need to flow to get 1 kg of CO2, which is where difficulty really is.
And is it then the power of the fan, or is it time?
Both. Yeah.
So what we do, we have fans on our collector containers that pull the ambient air through them. Inside we have these specialized chemical filters which bind with the CO2. We cannot go too much into detail with that. That's proprietary information. But once the filter is full or almost full, we close off the chambers on both sides and we apply heat. So we heat it up to around 100 degrees Celsius. In Hellisheiði, we use the residual heat from the power plant, so we can use that. The heat releases the CO2, and once it's, so when it has been released from the filter, we can collect it inside our process halls. Here we talk about either recycling or permanently store our current model is completely focused on permanent storage. And that is also why we are here in Iceland. That's our collaboration with On Power and Carbfix, as you probably heard about. Yeah, so if we go to the next slide. So here at Hellisheiði, we have the geothermal power plant, which provides us with the low-grade heat mentioned. We then send the CO2 to Carbfix that mixes it with water and injects it underground, where it becomes stone in less than 2 years. So over 95% of the CO2 that is injected into the ground binds with a basaltic bedrock and becomes calcites in less than 2 years. And the rest, I asked this question, I was like, what about the 5% that's left? It just takes a little bit longer, but it is not released. So, okay, that's the process up at Hellisheiði.
Yeah.
But how do we operate?
Yeah, so to be able to hire people, we need money. To have money, we need to sell to somebody. And so we're talking business model here. So our main customers are big companies that want to reduce their carbon emissions or wants to offset what they've done in the past. And for now, you're seeing some of these big companies, very recognizable brands, Microsoft, BCG, Shopify, Swiss Re is a reinsurance company, very big in the space as well, Audi, Stripe, and so on and so forth. So what we sell is conceptually a piece of paper to say that they have done a very good job by putting CO2 into the ground and that offsets emission. And what we do is that we capture carbon dioxide, put it in the ground, and we also have a third-party verification to make sure that this is certified, verified, that this is put away, stored permanently. Because that's the whole basis of the business. You need to make sure you develop something that you can sell to our customers, and these are the certificates that we sell to our customers. Now,
you just have a monthly subscription?
Usually what happens with big companies is that we sell them volumes. So we commit to selling them 1,000 tons for this year, and then over a 5-year period, every year is a certain amount at a certain price, of course. That's what we sell. Now, we also sell to individuals, so you can pay for a monthly subscription if you want to buy a few kilos. But to be honest, the bulk of what we sell is to companies.
And this is completely a voluntary market at present. So this is not part of the EU's emission system. So we usually sell to companies who have a large portfolio of solutions that they are buying from in order to reduce their carbon footprint. And this is a completely voluntary one. So they don't get any discounts or anything. But
it's really on their willingness to actually do something for the climate. So Climeworks in a few numbers. Since 2009, there have been about 15 DAC facilities, direct air capture facilities. You may be wondering why we only have 2, Orca and Mammoth. A lot of these are smaller facilities, pilot scale facilities that we have sold to other people to actually run them and do some pilot trials, for example, in Italy, in the UK. Apparently there's one in Japan as well. So quite a lot of experience there with smaller facilities, I would say. Today we have about 500 Climeworkers on this mission to fight climate change. Over 120,000 hours of operational experience in Orca, a bit in Mammoth now, and also across the many different testing and pilot plants that we have. We have raised a lot of money, $810 million, because at this point, it's not a business that actually we sell enough to pay for what you're doing. We are still using a lot of investor money to get the business up and running. And we have recently just delivered another 10 times scale up steps. So Mammoth is about 10 times bigger than Orca, and the plan is to go bigger than that.
Actually, our next project will be in the United States. So the Department of Energy in the US awarded Climeworks and some other collaborators with quite a lot of money to build up DAC facilities in Louisiana, North Dakota, and California. So Louisiana is first, and we are talking about what's the size of it?
250,000 tons per year.
Yeah.
So compared to mammoth, that's 36,000 tons a year. That's almost 10 times. And it could go bigger. 250,000 tons is opening ticket.
And we're looking at, we just got a large grant in Norway to do a feasibility study there. We've been doing tests in Oman, and we're also testing feasibility in Kenya with the Great Carbon Valley Agreement. I think we're missing the Canada project here as well.
Okay.
So we are not looking at just focusing on Iceland. What we need to operate a plant like Mammoth and Orca is a renewable, steady energy source and a good storage partner.
And people.
And people, yeah. In Iceland, we of course have this great basaltic bedrock and carbfix, so that's fabulous. There are other ways of storing carbon, so we are also working with other partners in other areas. Yeah. For example, in Norway, it's the Northern Lights project. My favorite is carbfix, but I'm a bit biased being Icelandic. So, how do we get to the gigaton scale that we wish to be at by 2050? Well, it's by massive scale up. And as mentioned in the video earlier, we have a modular technology. If you can see here, these are like little Lego blocks of collector containers. At Orca, we have 8 collector containers. These are container-sized units. At Mammoth, we will have 72 when it's completed. So it is a modular approach, which also allows us to test and adapt really fast to advances and learnings. Orca has been a big learning curve, and that's actually why it wasn't designed to be even bigger, because we wanted to learn from real-life operations. That's very different from a tiny laboratory. Yep.
I was wondering if you optimized the placement of these collectors.
Yeah.
You place them close to factories or?
Yeah. I mean, if you look at it, Orca is kind of designed in a square type of layout, whereas here is kind of a fanned-out layout. This optimizes for airflow. And in terms of where the plant is sited, Orca is actually a few kilometers from where the injection of the CO2 goes into the ground, whereas in Mammoth it's right beside.
And the location-wise, it doesn't have to be close to a large factory or anything, because the CO2 dissolves so incredibly quickly. Yeah. So you have the same level almost wherever you are. It fluctuates slightly according to northern and southern hemispheres and something like that, but largely.
Yeah, I mean, there will be other considerations that could drive where we put the plant. For example, I mean, being close to a factory could mean you use the waste heat from the factory, for example. But it's not the CO2 in the air that is really the concern here or the consideration here. It's other considerations, yeah.
But isn't that like the reason why it was placed where it is here in Iceland? Because you could use the residual heat from...
Correct.
The power plant.
Yeah. So is it like that in America and other places where do they get the heat from?
Yeah, I think the US project, Louisiana, there's actually, it's an area where there's really a lot of industrial activities and petrochemical activities. So you have this waste heat, you have expertise, you have your ecosystems in terms of maintenance, suppliers, and so on and so forth. So
you want to be close to some residual heat from some company? Or
that would be one of the considerations, yeah.
Also in Louisiana, that's also a turn from the petrochemical industry into a greener industry. So as in terms of creating job opportunities for the locals, going from like the oil to the climate.
Yeah. After Iceland had enough snow, so they say we'll go somewhere down south.
Yeah. Different considerations. One of the things that we experienced with Orca, like the first winter was so harsh that some like mechanical elements were failing, like the belts that move, the doors that close the chambers for heating up, they just froze over. So we had to change from different types of belts. And you know, technical things like this, mechanical things, but the technology itself worked as it should. So we were really happy with that. We've optimized quite a lot for Mammoth. So it's, I think like the full cycle for one of these collector containers is 2 hours for Orca and 1.5
about 1.5 for Mammoth.
So it's quicker and more efficient. So yeah, as you can see, the US here, we're looking at 200,000 tons here, and then multiply. And I mean, it will be quite a large industry if all goes as according to plan, and not just because of Climeworks, but because of other similar companies that we hope will join us. It's probably the only industry where you actually hope that you get more competitors, because that will actually be helpful in creating a real market.
Right, so talking about Mammoth here, so this is a photo of Mammoth in the winter. And let's go to the next slide where you have the video. Right, we just did inauguration of the plant last week. And this was the video that was shown at inauguration.
From capturing milligrams of CO2 in the lab back in 2009 to removing and safely storing thousands of tons of CO2 since 2021. From being doubted to being supported by millions. We always focused on the highest quality and leading edge technology to create the biggest impact possible. Today, we push the boundaries of what's possible even further. This is Mammoth, our second and the world's biggest direct air capture and storage plant, bringing us another step closer to reclaiming control of our climate future by removing megatons of CO2 in 2030 and a gigaton.
This is the Louisiana project, the visualization of it. Yeah. So just to give you all a sense of scale as well, over here is the Hidisedi power plant, power plant. This very small thing over here is Orca, and this is Mammoth. So you can see, even on Google Earth, you see a considerable difference in size, and this is really the scale up happening. Okay. Yeah. In terms of numbers, so we're talking about 36,000 tons of CO2 per year at nameplate. 72 collector containers. We want to run this for 25 years, at least in the spreadsheet. I want to run this for 100 years. This is equity finance, which means we use investors' money to pay for this. 50,000 square meters in terms of size. We talk about geothermal energy just now. Carb fix, we talk about that. In terms of workforce, we're talking about 20 to 30 people in terms of O&M. So we're building it right now. We're building the team right now. And also at this point in time, we used to have about 100 people in the last few weeks. That was because of the construction phase still ongoing. So it's in the phase of construction handing over to operations right now. And we're going from about 100 to 30 over the next years. The construction people will just leave the site. A lot of them are coming from many different countries to work for the project, just for the construction. Local partners, we're trying to develop local relationships as well to work with local partners. Carb fix and on, of course. HD, our good friend there, Daniel, who has been supporting us very strongly to get the plant running. Rough Millen for electrical work, Raphael as well, electrical work, Securitas, fire systems, Sindri for some specialized equipment, other suppliers like Rubix as well. So we're working a lot of, we want to build up the relationship with the local partners who service our plants. Yeah, so coming to what is important today, we are looking to hire quite a number of positions in Iceland. We want to build a dedicated engineering team here. So what that means is that we need process engineers. We also need DCS, distributed control systems, and controls engineers to be able to run the systems, to understand the DCS. In the operations team itself, we're looking for people like process engineers, process operators, maintenance manager, maintenance planner, maintenance engineers, both mechanical and electrical. For Mammoth, in the Orca side, some needs as well for production supervisor, maintenance engineer, electrical. We're looking for someone for safety, occupational health and safety representative. And a very important position, the last one, an OEM field service engineer. Essentially what that is that's the guru for the CCs, the collector containers. Because we own OEM. We are our own original equipment manufacturer for the collector containers. And we need someone to understand that inside out to be able to do repairs, but also bring feedback back to the manufacturing team for the next ones.
A lot of growth opportunities in the company.
Yeah, I think we'll skip this slide. If you're interested, this is just the different teams talking. You can find it on our website. In terms of benefits and perks here in Iceland, we have an annual snow weekend where we go skiing. This is a tradition because it's a Swiss company. They like skiing in the Swiss Alps. So every year they do one in Switzerland. This year we started doing one here in Iceland as well. We went all the way up to Akureyri. Beautiful weekend. Had a good time. There are remote sessions organized in Switzerland that we can join here in Iceland. Boot camp sessions, yoga sessions, employee communities. And we have financial contribution for professional development, referral bonuses. Vacation days, 25 days per year. We have relocation support for those relocating from Iceland. Obviously, from Reykjavik to Helsinki is not included in that. Insurance coverage for accident and sickness. We do carpooling from Reykjavik to the plant. And it's definitely a very purposeful workplace where there's a very strong alignment with the mission. A lot of people are there to for the mission, and a very strong team culture. One of the Times 100 influential company, 2022. Good, very interesting environment to work in where people work very well together to solve problems, to scale this thing up, direct impact and endless growth opportunities. I also like to highlight that in the team today, we have 9 people with 9 different nationalities. So definitely a very diverse environment. It's a race to see which nationality will win in the end. We have 1 Icelander, 1 American, 1 Canadian, 1 Malaysian, 1 Singaporean, 1 Romanian, 1 Portuguese, 1 Finnish. So it's kind of like we are equal right now, but next month we have 1 Icelander, 1 Canadian, 1 Americans coming in. So the race is getting very, very strong. And I hope the Icelanders will win in the end.
Yeah.
Right.
I just want to add that, I mean, Mammoth was a little bit in the news in Iceland, but it was a lot more in the news all over the world. We were on CNN, BBC, live on CNBC, and maybe the greatest of all, no. Yeah. We were on Saturday Night Live, quoted. So I think that's a level of fame, right?
Yeah.
Some sort. Yeah, they were making fun of us being in a giant vacuum just in time for Mother's Day. But you know, we were on the radar, okay? So we have sort of concluded what we wanted to say, and we also just wanted to ask you what you wanted to know, and just feel free to ask us anything. We'll try to answer as much as we can.
With the snow, have you done any measurements of like the levels of CO2 in the air from summer to winter? Or is there any variance?
Yeah, there isn't much of a variance in terms of CO2 concentration in the air between summer and winter. The variances we do see is in the performance of these things. A lot of breakdowns more in the winter compared to the summer because of issues that you can imagine, freezing. Within the freeze and melt cycles, you have issues as well.
Maybe you have dead months. Like
I mean, so we have fluctuations in the performance of these collector containers. Now, for example, it's performing very, very well just because you have good weather, just like how every one of us is so much happier, right?
The first winter was the worst for Orca, but the second one was already quite a lot better, and the third one much, much smoother than the first 2. So it's a learning curve operating in real conditions.
Like, is there any variance, like just in the static?
I don't believe so. I don't believe so. Yeah, I mean, if you think about it, the CO2 does not deposit between different areas, so it's going to be pretty constant across.
Yeah, there have been some tests made in like how the filters work in different conditions, like for increased moisture in the air, etc. I don't have all those measurements, but
we do have those relationships. So humidity is a big impact on the performance of the solvent material, the filter material inside the collector containers as well. And it doesn't really like a lot of humidity.
No.
Yeah. Yeah.
Relative humidity or.
Correct.
Correct.
Because we have a lot of high.
Yeah. We all know that, right? I mean, winter is tough for everyone. Same for our collector containers. Yeah.
In terms of scalability, is it like just a question of quantity over quality, or do you need like bigger fans or more powerful fans, or is that
correct.
Like a point of diminishing returns? If you have too powerful, does it matter? Or sweet spot?
Right. Yeah. The way this was designed is a modular system, so that you can actually scale it just like solar panels. You want more, you put more solar panels. Mm-hmm. So you want more, you put in more of these collector containers. That's the thought behind how this was designed. We're not necessarily going to put bigger fans on them because mechanically you cannot take a much higher weight on these collector containers either. You can definitely think of, hey, let's put bigger fans, push more air through, we get more CO2. At the same time, there's this consideration of energy costs. It takes a lot of energy to have bigger fans as well. So there's a trade-off there that we need to be mindful of, because ultimately we need to get this down to a cost competitive level.
But you talk about amount of air when you want to place it then where it's super windy, so you get the wind placed.
Right, yeah. So I think in Iceland you can place it anywhere. It's super windy anywhere. So yeah, so I mean I can close my eyes and do that in Iceland. The fans actually do a lot of the job of pushing the air through, I would say. I don't think this consideration was too much taken into account for Iceland, to be honest. For the future plants, that could be one of the considerations besides waste heat, besides suppliers, so on and so forth, and putting where we put the containers,
Is it like the future business plan, is it always dependent on companies buying quotas?
Yeah, it's going to be that way. What we would like for, obviously, I don't make policies, but what we would like for is that this becomes mandatory, that companies would have to account for their carbon emissions somehow, and this would be one of the tools that they would have in their toolbox to do that.
Yeah.
So it would be essentially government paid through taxes, CO2 taxes on companies that get paid. And
you can look at different models, but if you look at maybe companies, they pay to have their trash recycled. So this could be a similar thing. You just have to pay. If you emit, you pay for the removal. Yeah. I mean, if you think about it, we have been using the atmosphere like a trash bin, putting our CO2 out there. You don't put your trash out on the streets and not pay for it to be taken away, right? To be put in landfills. So it's kind of the same concept that we would like to happen, that we like to see in the future. And I mean, it makes sense because we are dealing with the problems of CO2 right now in the atmosphere because we didn't do anything about it in the last 50, 100 years. Yeah.
So we have to pay to fart, basically.
If you're, I mean, I mean, I'll leave it there.
That's part of the unavoidable emissions, therefore. Yeah, but I mean, also credibility is then, of course, key in building up a new industry like this. We had to develop a full chain methodology from scratch, which was DNV certified, third-party verified. We did this with Carbfix, and this is something that the next direct air capture companies can utilize to also certify what they're doing is what they're saying they're doing.
It's a very new industry, so everything is, people are trying to understand everything, build out the systems, the entire ecosystem for all of this.
Yeah, from scratch. Creating a market, to get the regulations in place, to make sure everything is okay, and that's a lot of work.
How much electricity do you use to capture 1 kilo of carbon?
1 ton would take about 2 megawatt hour.
So you have to use renewable energy to use it.
Yeah, I mean, this only makes sense if you use renewable energy or some sort of a waste energy, because you're not going to burn fuel to capture CO2. Yeah.
Do you have any byproducts?
Byproducts, as in what we do with the carbon dioxide? Yeah. So interestingly enough, the first commercial plan that Climeworks had was to sell CO2 to Coca-Cola, to make Coca-Cola carbonated water. But unfortunately, we're not paying enough for Coca-Cola, so we stopped that and we sell certificates instead.
Yeah, so I mean, you can always sell the CO2 that you make, but there is way too much of it. So we wanted a permanent solution, which is, yeah.
There may be a day where we're able to reduce the cost by a lot, and there's an incentive for companies to use the CO2 in other ways. For example, Carbon Recycling International uses CO2, right, to make methanol, I believe. So could they use our CO2? Yes, but we are too expensive right now compared to what they need.
And it is expensive. First of its kind technology is always expensive, but we are looking at we're hoping for a cost curve that is somewhat similar to that of solar. So really expensive at first, but with advances and
and scaling as well.
But of course, when you're creating the supply chain from scratch, that's also more expensive. Yeah.
Anything else?
Maybe, like you said, it was proprietary information, but like the filters inside, it's just like some kind of match filter that catches the CO2 molecule.
It's a chemical product that we put inside, and it's very similar to water treatment chemicals. I'm not sure what do you know Brita filters that you use to do purified water at home? It's very similar to what you have inside the Brita filters.
And they are, of course, we don't change them every time, so they can operate for up to 2 or 3 years before we need to change them out. So it's recycled.
Yeah, that's what we are developing right now, finding avenues to recycle the solvent so that we can actually bring it back to use it again.
How long does it take for one box to be filled up and closed up? Like hours or days or weeks?
Yeah.
Before you heat it up?
Yeah. So when you say filled up, you mean putting in the material for
like the whole cycle of this?
And heat it up and
okay. About 2 hours for orca, 1.5 hours for mammoth, somewhere around there.
So it's like constantly.
And it's just like always one emptying out, and so that it just.
So it doesn't take a long time to fill up the critical.
No. And if you ever go up there, and you can usually see the doors, you can see them from the other side, from here, like behind the TV. You can see the doors moving, and then when they release the steam, you can watch the process.
Yeah, I think it's the question of getting enough air through the system. You could enclose it, of course, but I think that will create a lot of, you need to push a lot of air through the building to actually get it through the collector containers,
So what about just a roof?
Yeah, that's possible. That's possible. Whether that will give us value add is something that we need to look at. Cost benefit analysis. Of course, we are trying to do this as the most cost efficient manner. Yeah. Other questions? Yeah. All right. Thank you, everyone.
Thank you.